Hi, Mr. Keitlinger here. August the 9th, 2017, Selby, South Dakota. My producer and assistant, Jessica Arts, coming out. Jessica, say hi again to my pre-calculus class and say hi to the world. You don't know who's watching us.
Hello, everyone.
Yesterday I was in Aberdeen. Justin, Miranda, Autumn. I golfed at Rolling Hills Golf Course and I got under 100. Not for 9 holes, but for 18. I didn't think that would ever happen to me again, as lousy as a golfer I am. I got 49 the first round and 46 the second round, and I didn't cheat. Those are legitimate scores, so I was excited about that. Okay, today we're going to work on the remainder theorem and the factor theorem, but we just have to touch on a little bit of what we did earlier with something. We did a few lessons ago. If we were finding f of 1, this is our normal strategy. Whatever normal is, I'll put the 1 in, and 1 to the 5th is 1. 1 times 1 times 1 times a negative 2 is minus 2. 1 times 1 would be a plus 1, and then my minus 4. Looks like I'll get a negative 4, so there would be my f of 1, and that's what I would call normal. However, using synthetic substitution, we can do this. I'm going to copy down the coefficients. So I've got 1 of those x to the 5ths. I've got 0 of those x to the 4ths. Be careful there, we don't have any x to the 4ths. I've got a negative 2 of those x to the 3rds. I've got 1 of those x squareds. We have 0 of those x to the first powers, and then we have the negative 4. Okay, I'm not doing anything new. This is from a few lessons ago. I'm going to draw a line down here, leave a little bit of room, need a little box over here, and if I'm finding f of 1, I will put a 1 in the box. Okay, and this algorithm, this is an algorithm, it has nothing to do with Al Gore, the climate change guy, who drives all over the world in his jet, who thinks that you and I should walk Jessica so he can fly in his jet, so we don't leave a big carbon footprint. Enough politics for now. Okay, I'm going to bring this first number straight down, okay, and then we multiply it by what's in the box and add. Multiply by what's in the box and add. Multiply and add. 1 times 0 is 0, and add, multiply, and add, and our last number, there's my answer, and that should be the same answer we got here. That's our synthetic substitution. Okay, this is a different way of doing this problem. On your next test, it might say, find f of 1 using synthetic substitution. Now I'll expect you to use this manner. You'll have to show me that on your paper. If I just say find f of 1, I would go to that old normal way. Okay, next we also did synthetic division earlier. Okay, now I've got this polynomial, this quintic, because it's x to the 5th power, divided by the x minus 1. If we have to divide that into there, I'm going to do almost the same thing I did over here. I'm going to copy down my coefficients again. Okay, make sure you put 0 because I have 0 of those x to the 4th. Put a 0 there because I have 0 of my x terms. Okay, I'm going to put down a box again. Okay, back to synthetic substitution. If we were finding f of 1, I put 1 in the box. With synthetic division, if they're dividing by x minus 1, then we're going to put a positive 1 in the box. Okay, I'll go through the same thing I just did over here. Okay, and it looks exactly the same as what I did over here, except now we have a different meaning. I started with an x to the 5th divided by an x. If you ever saw this in Algebra 1 class, you would have said that's an x to the 4th power. X divided by an x, we would write down our x's and subtract our exponents. Okay, so here's an x to the 5th divided by an x. I should get an x to the 4th, so what that means here is I have 1 of these x to the 4ths, plus 1 of those x to the 3rds, minus 1 of those x squareds, and then I've got plus 0 of those x's, and then plus 0, and then that's my remainder. My remainder is a negative 4, and I'm going to write this like this, minus 4 over x minus 1 being we divided by the x minus 1. Okay, so there we use synthetic division to do that, and you're going to have to do that on some problems in today's homework also. Jessica, does that synthetic division ring a bell at all? Looks like something you did in pre-calculus, maybe algebra 2. It's an algorithm. Some smart guy figured out that it worked, or girl, figured out that it works, and we can use that. You can also divide that using long division, which is more work. That problem, this is the easiest way to get your answer. And what we found is the quotient and the remainder on that problem. Okay, now let's get to the new stuff. Remainder theorem and factor theorem. Are the Vikings going to be a factor in the North Division in football this year? I doubt it. Okay, but it's not that kind of factor. Our factor theorem, we're going to look at this. If I have 32, and I ask you, is 5 a factor? We could divide by 5. Let me go like this. Is 5 a factor of 32? You'd say no right away because that doesn't go into there, but we could go like this. Goes in there 6 times, and we'd have a remainder of 2, so no, it's not a factor. 6 remainder of 2. Is 5 a factor of 33? And you guys should know right away it isn't. That goes in there 6 times, and we'd have a remainder of 3. Is 5 a factor of 35? Okay, and that goes in there 7 times, and we'd have a remainder of 0. There's none left over. Is 5 a factor of 60? Goes in there exactly 12 times, we have a remainder of 0. Okay, so I should have waited till factor theorem to go over these examples. Oh well, keep this in your memory bank for a little bit later. Okay, but we got the remainder on each of those. 2 is my remainder of 3. Nope, that doesn't look like a third power. It does, but it's just supposed to be a remainder of 3. Remainder of 0, remainder of 0. Okay, here's how it's going to apply to this problem. Bear with me. Okay, your directions in today's homework, it's going to say find the remainder by using the remainder theorem. By using the remainder theorem. And that's going to be new for you today. And you will want to use the remainder theorem. You could use synthetic division to find the quotient remainder, but you have to put a lot of zeros down. You'd have to put a 0 for all those we're missing in between 96 and 62, and a bunch of zeros there, and a bunch of zeros there, and a bunch of zeros there, and you don't want to do that. Okay, so here's what our remainder theorem tells us. Remainder theorem. If I'm dividing by x minus a, we're going to take f of a, and that's going to be the remainder. If I'm dividing by x minus a, we'll take f of a. Okay, I'm going to divide this thing by x minus 1. Divided by x minus 1. Okay, and I'm going to say find the remainder using the remainder theorem. So you're going to go remainder theorem, and this is on your homework, right on the top of the page. If I'm dividing by x minus a, f of a will be the remainder. Okay, so I'm going to do this. F of my a in this case is a 1. If that's x minus 1, then this is a positive 1 that would be in our parentheses there. I'm just putting this into the numerator. If I put the 1 in, 1 to the 96 is 1, 2 times 1 is 2. If I put the 1 in, I get a negative 3 times 1 is a minus 3. If I put the 1 in, I get a minus 5. If I put the 1 in for all those x's, I get a plus 4. If I put a 1 in, I'll get a minus 8. And this should give me my remainder. See what we have here. Here's about a negative 16 plus 6 would give us a negative 10. There's my remainder. We're done with that problem. And that is the easiest way to do this problem. This is exactly what you'll want to do on this problem. Next one. Okay, I'm going to find the remainder, and I'm going to use remainder theorem when I divide by x plus 1. If I'm dividing by x plus 1, I'm going to have to take f of negative 1. Okay, be careful with your signs now. A negative 1 times itself 96 times would be 1. 2 times 1 is still a 2. If If I put a negative 1 there, and for those x's, I'll still get a minus 3. A negative 1 to the 55th power will be a negative 1 because there would be 55 negatives. There's another negative, so I'll make that a positive 5. And if I put a negative 1 there, that would be a positive 4. And then copy your minus 8 down, and this should give me my remainder. And that's all it is. That's our remainder, 0. Okay, if I don't mess up here, there's about 11 minus 11. Look at that. My remainder here is going to be 0, and we used our remainder 0. And you want to use remainder theorem on this problem because you could do it with synthetic division, but you have to put down so many zeros. Nobody wants to do that, and I certainly don't want to correct your paper when you do that. Okay, next problem. These are pretty easy when I put the 1 in and when I put the negative 1 in. Okay, I want to find the remainder when I'm dividing this polynomial by x plus 3. The remainder theorem says when I'm dividing by x minus a, I'm going to take f of a. So if they're dividing, let me erase these two. They were easy. Okay, and careful now. If they're dividing by x plus 3, we're going to take f of negative 3. Cassie. Negative 3 to the 96th power. That's a really big number. If you're in your calculator punching out quantity negative 3, close it off, raise the 96, it'll give you some ugly looking number that's got the E at the end. You don't want to mess with that. This would be a horrible problem. When that was a negative 1 and a 1, that was a decent problem. This one, I'm not going to ask you to do. Nobody will be. If I ask you to do that, you march down to Mr. McFarland and tell him to fire that guy in there. He's losing it. Okay, remainder theorem. That's it. Okay, factor theorem. Jessica, I told you I wasn't ready to go tonight when I got here. When I did that 32 divided by 5, and that 33 divided by 5, and then that 35 divided by 5, and then that 60 divided by 5, I want to do that right before I did this. Hopefully I haven't forgotten all about that yet. Okay, I want to find out if x minus 1 is a factor. If x minus 1 is a factor. Okay, it's a factor if we get a remainder of 0. It's a factor if we get a remainder of 0. Okay, so I'm going to use the remainder theorem again, and we actually call this now the factor theorem. The remainder theorem and the factor theorem are really the exact same thing. It's just the factor theorem. I will use this, and if you get 0 for a remainder, then yes, it's a factor. If you get a remainder of 0. So doing this exact same thing on this problem, if we're dividing by x minus 1, then I'm going to take f of a positive 1. We always use the opposite sign of what they have in here when I use synthetic division. When it was synthetic substitution, we use the same sign. Here it's the opposite. So f of 1, I like putting 1s in. Don't watch me mess up. I did about the negative 48. Looks like about a negative 48 to me. Is that a 0? That's not a 0. That's a negative 48. That's my remainder. If we have a remainder of negative 48, then my answer is going to be no. That's not a factor. So when they ask is x minus 1 a factor, right there we are. Use your remainder theorem. If that's my remainder, then no, it's not a factor. Next one. Let's see if x plus 1 is a factor. X plus 1. Oops. I want to find out if that's a factor. Again, I use the factor theorem, remainder theorem, same thing. If I'm dividing by x minus a, I'm going to take f of a. This is the same as x minus a negative 1, so this time I will take f of negative 1. We use the opposite sign. dividing by x minus a. Notice that has the opposite sign of what that is when we decide what to put in there. Okay, careful with your signs. I'll have 4 negatives, that'll be a positive 1. I'll have 3 negatives, that'll be a minus 3. There would be 2 negatives when I put the negative 1 in. 2 negatives, there's another one. 3 negatives makes that a minus 7. If I put a negative 1 there, that'll be a plus 27. And I'll copy that minus 18 down. I'm just putting a negative 1 in wherever I see an x. Let's see what happens on this one. Jess, what's negative 10 minus 18?
Negative 28.
Negative 28. Look, here's positive 28 minus 28 is 0. This is my remainder. If my remainder is 0, then my answer is going to be yes. That is a factor. So you're finding the remainder. If your remainder is 0, then we can say yes, it's a factor. Your question here is going to say, is x minus 1 a factor? No. Is x plus 1 a factor? If you get a 0 there, then your answer is going to be yes. Okay, try this one yourself. Mrs. Begum, if you could pause it as soon as I get the problem on here. I want to know, is x plus 2 a factor? Is x plus 2 a factor? Go ahead and pause it, Mrs. Begum. It looks like most of them are done, then you can start it again. I believe we get a 0 here. Jessica's going to double check me. But I put the negative 2 in. I hope I was careful with my signs. They're dividing by x plus 2. If they're dividing by x plus 2, I'm going to take f of negative 2. That's my remainder theorem. Okay, and if I get 0 for my remainder, then my answer is yes. This will be a factor. That's it. Factor theorem, remainder theorem. Okay, but we're not done yet. Okay, next problem. I'm going to say find the quotient and the remainder. Okay, find the quotient and the remainder. Okay, when I'm dividing this quartic, because it's the 4th power, quartic polynomial by x plus 2. Okay, now I want more than the remainder. This remainder theorem just gives me the remainder. That's all. Okay, so now we have to go back to synthetic division on this problem. If we ask for the quotient and the remainder, back to synthetic division. Here we go. I'll copy down my coefficients. Got 1 of those, 3 of those, negative 7, a negative 27, a negative 18. I'm dividing by x plus 2, so we'll put a negative 2 in the box. I'll bring down my first number. Jessica, multiply.
Negative 2.
And add.
Negative 1.
Add.
1.
Multiply.
Negative 2.
And add.
Negative 9.
Multiply.
18.
Yep, we all know how to multiply and add. Add.
Negative 12.
Add. Negative 9. Yep, negative 9.
I knew that.
And multiply.
18.
And add.
0.
You should be happy you got a 0. Because then we find, when we asked if this was a factor, we said yes, because we got a remainder of 0, so I should have gotten a remainder there again. Okay, so here's what's left. I've got an x, and I'm doing old stuff, we did this before. That's an x to the 4th divided by an x. So that would give me an x to the third power, so I've got 1 of those x to the thirds, plus 1 of those x squared, minus 9 of those x's, and then minus 9. Okay, and that is I asked for the quotient and the remainder, but we do not have a remainder. Mrs. Begeman, can you pause this in just a second and have me do this problem? I want to find the quotient and remainder when I divide by x minus 2. Okay, go ahead and pause it. Everybody find the quotient and the remainder. Okay, I hope I did this right. I hope I don't have any silly mistakes in there. But if you're dividing by x minus 2, we're going to put a positive 2 in the box. And I have to go to this method. Don't go to the remainder theorem, because that just gives me the remainder. Here we want the quotient and the remainder, so we have to go to this stuff that we did a few days ago. Once I get to here, this is an x to the fourth. I divided by an x to the first. So this is 1 of these x to the thirds, minus 5x squared, plus 3x. And then minus 21, this guy is my remainder, and I'm going to write this like this, minus 60, and we divided by x minus 2, so minus 60 over x minus 2, and there would be okay. Then we've got one more thing we have to do yet. One more thing. We've already covered this, we've already covered this. Okay, we're going to solve for x, but I'm going to give you a little bit of help on this problem. Miranda, how many answers should I get for this problem? Regina, did she say 4? Yep, I should get 4 answers for this. So we can go to our rational root theorem and do this problem, but that's quite a bit of work when I got an x to the fourth there. So I'm going to give you some help. I'm going to tell you that 2 of the answers, one answer is x equals 1, another answer is x equals negative 3. Now, Miranda and Regina and I say there's going to be 4 answers. There's 2 of them, so we have to find 2 more. 1 is an answer, 1 is an answer. Well, if you want to, you can put 1 in for those x's, but you're going to end up with 0 equals 0, so you'll go, yup, he wasn't lying, 1 really is an answer. Here's what I want to do with that. If x equals 1 is an answer, then x minus 1 must have been a factor. If 1 is an answer, that must have been a factor. If it's a factor, then it divides it in there evenly. So let's divide it into there. Okay, in the box, I'm dividing by x minus 1, so I'll put a positive 1. I'm not doing anything new. I'll copy down my coefficients. Careful I don't miss anything. I don't see any terms that are missing, so I don't need any zeros. Again, if 1 is an answer, then x minus 1 must have been a factor. If x minus 1 is a factor, I'm going to divide it into there. And we're using our remainder theorem to divide it into there. Bring down my first number, multiply and add. Multiply and add. Multiply and add. Multiply and add. And you better get a 0 here. If that's an answer, then x minus 1 has to be a factor. And if x minus 1 is a factor, you better not get a remainder. Okay, here's what I have now. That's an x to the fourth. I divided by an x, so this is 1x to the third plus 4x squared minus 2x minus 15. But I'm not going to write that down. Now I'm going to go to this thing. If x equals -3 is an answer, Justin, then what? If you want to, you can put -3 in, and you'll get 0 equals 0, and you'll go, yup, then Mr. Keitlinger was not lying, it really is an answer. But that's not what we're going to do. If -3 is an answer, then x plus 3 should be a factor. And if x plus 3 is a factor, then I'll put a -3 in the box. You don't have to pay any attention to that 0 at the end. Synthetic division, here we go. Jessica, multiply
-3.
and add.
1.
Multiply
-3.
and add.
-5.
Multiply
15.
and add.
0.
Why are you smiling? Are you happy you got a 0 there? Yep. If -3 is an answer, then x plus 3 has to be a factor. If x plus 3 is a factor, you better not get a remainder back there. Okay, I started with an x to the 4th. I divided by an x, divided by another x, so that should get me to an x squared. So what I have left here is 1x squared plus 1x minus 5. Okay, I have that left. I'll try to factor that, it won't. We got to go to quadratic formula. Here we go. That'll be 1 plus 20, would be a 21, over 2. There's my other two answers. 1 is an answer, -3 is an answer, a -1 plus the square root of 21 over 2 is an answer, and a -1 minus the square root of 21 over 2 is an answer. There we got our other two answers. So important thing on this, if that's an answer, then x minus 1 is a factor. If x minus 1 is a factor, then divide it into that polynomial using our synthetic division. You better get a 0 at the end. If you don't, you made a mistake, or else we lied. It's not an answer. Then if -3 is an answer, then x plus 3 is a factor. If x plus 3 is a factor, use synthetic division to divide it into there. I'm left with 1x squared plus 1x minus 5 equals 0. And it won't factor what Mrs. Roush taught you how to use quadratic formula in Algebra 2, and we did it earlier this year in pre-calculus also. Okay, so see you guys in a week or so. I'll be back from Germany. This will help you with homework number 30. Over and out.